In this example, I'm going to show you how you can use RStudio to simply calculate a confidence interval for a matched pairs procedure. So let's go ahead and read the scenario. It says Blastobike, a bicycle manufacturer, claims their bike will increase speed and hence reduce route times for cyclists. A simple random sample of 5 competitive cyclists were asked to record their times on the same route while first riding a standard racing bicycle and then riding the Blastobike. The population of route times is normally distributed and the times in minutes are recorded below. So the standard times are here and the Blastobike times are here. And so we know that this is paired data because there are 2 measurements on one cyclist. Their first standard time and then their Blastobike time. So 29.1 would be the recorded route time for the standard bicycle for the first cyclist, and their recorded route time for the Blastobike would then be 28.3 for the same cyclist. So this data is paired, so it's important that we take the differences and talk about the average of the differences rather than the difference of averages. So the first thing that we should do is take the differences between these 2 times. So we can do this by creating a new vector called diff. And this is equal to standard times minus Blastobike times. And so I first need to run in standard times and Blastobike times. Then if I run in diff, I get a new vector called diff. It shows up over here. And I can write, if I just run just the name, the vector name of difference or diff, then I get 0.8, 1.4, 3.7, 3.6, and 1.8. So basically this just took the differences between the route times for each cyclist. One little side note is that if we notice that all these times are positive, what that means is that the Blastobike time was that much less in minutes than the standard time. And we have to think about which way we subtracted in order to be able to give that some context. So 0.8 minutes, a positive 0.8 minutes basically means that the Blastobike for the first cyclist was 0.8 minutes faster on the Blastobike time or the Blastobike route than the standard route. So that's important to understand when making inference. So if I want to calculate the confidence interval, I'm first going to call this d bar, and this will be equal to the mean of the difference vector. So this is the average of the differences, and I get that to be 2.26. I can now find the standard deviation, which I'm going to call SDD, standard deviation of the differences, and this is then, the command is SDDiff. If I want to look at that, I can just highlight these 2 lines. Oops, but I have to type it in right, so this is SDD, little error here, that's okay. And I get 1.318, so 1.32. Now, if I want to do a 95% confidence interval, I need a critical value. And so the critical value that I'm going to use is for 4 degrees of freedom because I have 5 differences in total. And so n minus 1 is equal to 5. And to get that critical value, I could either look it up on a t-table, but I'm going to use R because I'm already here. And if I want a 95% confidence interval, then I need to put in a quantile value of 0.975. Put in my degrees of freedom of 4, and run this, I get a critical value of 2.77644. So I'm just going to call that t-crit. All right, and now I can set up my confidence interval. So I have d bar minus my t critical value times my standard deviation, which is SDD, divided by the square root of my sample size. So in that case, there's 5 differences, so that's the square root of 5. It's not 10. We always look at the differences rather than the total number of observations when we're talking about a matched pairs procedure. All right, so now I have my margin of error. I'm subtracting it off my point estimate, D bar, and this will give me my lower bound, which is 0.623043. And if I want to find the upper bound, I can just copy this line and just change this to adding my margin of error. And I get an upper bound of 3.8969 minutes. All right, so that's one way that I can calculate the confidence interval. I can basically use R and kind of do it by hand, or I can use the t.test command. Again, a matched pairs procedure is basically just a t-test on the differences. So if I put in diff here, the default is the mean will be equal to 0. I don't need to do anything there. I just put in a $ conf.int, and this will give me just the confidence interval from a t procedure. And sure enough, I get the exact same values as I did when I did it by hand. So t.test of the differences, conf.int will be then the thing that I want to pull out of this output. I can pull it out using this $, and I get the exact same lower bound and upper bound with this short key command. All right, so hopefully this video helped you understand how you can calculate a 95% confidence interval to estimate the mean difference.